With angle bisectors, we're going to start with the angle bisector theorem, and that says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So I put this point D on this angle bisector that I have drawn, and this theorem says that D is equidistant to both sides of the triangle, or the angle. Now we say equidistant, but we threw in these right angles, and that's because anytime we look at the distance from a point, like point D, to a side, we have to look at the perpendicular, and that's just a rule that we use for measurements with points and lines. So that gives us right angles. If we added the reflexive property, we can start to see that these two triangles, in terms of triangle congruence, would be congruent by angle, angle, side. And because of that, you would have corresponding parts of congruent triangles making these two parts congruent. So the background of it is in triangle congruence. Now in the context of what we're looking at, we're saying that that point is equidistant to the sides. Now the converse of it is saying if you have an angle and you put a point that is equidistant to the sides, so now it looks like a hypotenuse leg type of situation. If we have that, then it's guaranteed to bisect the angle. So we start, instead of with bisecting to equivalent, we have, or equidistant, we have equidistant to bisecting. Still works the same, still uses our triangle congruence. Now, when we then take three angle bisectors and put them within a triangle, they all meet at a common point. That common point we call the incenter, and they find out that that is equidistant to the sides of the triangle. So where the angles are bisected, it's equidistant to the sides. Now I'm going to draw this poorly here, but if I then came in and drew a circle, this point here would be how you inscribe a circle within a triangle, because that equal distance to the sides would be the radii around the circle. Now, angle bisectors are AP, BP, CP. They meet at point P, our incenter. And then I have that equal distance to the sides, but I also have that DA and FA are congruent, DB and BE are congruent, and CF and CE are congruent. And that's because this is really almost looks like, if we cover up some parts of it, this is little kites that I have making them up. So I have one kite here, there's another kite, and then a third one, and that type of congruence works for us as we're looking at the incenter and angle bisectors. Now we'll kind of come back to that. Let's look at just solving angle bisectors by themselves. So I have to find PQ. So this is an angle bisector. We're saying it's equidistant, so we go 8x minus 27 equals 4x plus 33. We subtract 4x from both sides and we add 27. I get 4x equals 60, which gives me x is 15. So then PQ is 8 times 15 minus 27, which is 120 minus 27, or 93. For the next one, the measure of angle BDC, which is this one right here, we're saying that they're equivalent in distance from B to A and B to C, so therefore we can set the angle values equal. 9x plus 5 equals 12x minus 19. I'm going to subtract 9x and add 19. We eventually get to x equals 8. We then substitute into the measure of angle BDC, 12 times 8 minus 19. That gives us 96 minus 19, which is 77 degrees. Now you may be asked to find other angles here. If this is 77, this would also be 77. Together, 154. Since I have a right triangle and this is 77, that's 13 degrees, because I have to add to 180. That would be 13 degrees, and then 26. So just be careful what it's asking for. Finding x is very good, but you got to make sure you answer the question that you're given. For our next one, we need to find x. They are corresponding congruent parts. 10x minus 1 equals 14x minus 37. I'm going to subtract 10x. I'm going to add 37 to both sides. I get 36. So it gives me x equals 9. I didn't need to substitute in. That's all I needed. Next one, I need to solve for ML. I'm going to say 2x plus 5 equals 5x minus 4. We're going to subtract 2x from both sides. We get 3x. I'm going to add the 4. I get 9. So x equals 3. Now ML, we're going to substitute into 5x minus 4. So that's 5 times 3 minus 4. 15 minus 4 gives us 9. No, it doesn't. It gives us 11. For the next one, this was the same as the previous problem. If you've noticed that, it's right there. It's 77. We don't need to solve that one again. It's the same as that bottom one on the first page. Let's go here. The measure of angle YWX, which is the whole thing. So I'm going to have to find each angle and then substitute in after I find x and find the total. So we're going to go 9x minus 28 equals 5x minus 8. We subtract 5x, we add 28, we get x equals 5. Now when we substitute that in, I get 25 minus 8, which is 17. Then I get 45 minus 28, which is also 17. So the measure of angle YWX would be, you could combine the two and make it 34 degrees. Last part here, I have to find a bunch of angles, and I start with some values here to work. So PRQ, which is the angle at R, RPQ, the angle at P, and PQR all have expressions with x in them. Now I know these all add to 180. So I'm going to start with that. 4x minus 14, 7x minus 5 equals 180. So we have 19x. That looks like a minus 10 minus 14. That's minus 29 equals 180. So we're going to go 19x equals 209. So x is 11. So if x is 11, I need to go back and find the angles. So the measure of PRQ, or 8x, 8 times 11 minus 10, is going to be 78. The measure of angle RPQ, 4 times 11 minus 14, or 44 minus 14, 29. And the measure of angle, that's not 29, let's try again, 30. And the measure of PQR, which is 7 times 11 minus 5, or 77 minus 5, 72. Quick check, 78 and 72 is 150, and 30, so it does add to 180. We're off to a good start. So now when it asks for RPS, RPS is half of this angle. Now I found earlier that this angle at P was 30 degrees. R was 78 and 72. Now it's not the best way to label the angles, but just kind of help us because we are going to be bisecting them. That makes this angle 15, 15, 36, 36, 39, and 39. So RPS is 15. PQS is 36. PRS is 39. And now last, PSR is this angle here, which, if I know 15 and 39, I can find the missing angle. Together, 15 and 39 is 54, so 180 minus 54 gives me 126 for the angle PSR.